Good afternoon. It's noon now, right? My name is Wenxuan Guo with Plant Soil Science at Texas Tech. I also work with Texas A&M AgriLab Research. The graduate council of this department and I are helping this department organizing and coordinating this seminar series of 2024. And Rupert Karn with the graduate council, they are doing a fantastic job doing this seminar series. Let's take this opportunity to recognize them. Today, Dr. Katharine Hayhoe will give us talk on climate change in agriculture. What a great honor. Dr. Hayhoe is an atmospheric scientist. She is the chief scientist for Nature United and for its affiliate, the Nature Conservancy. She is a Horn Distinguished Professor and Endowed Professor of Public Policy and Public Law in the Department of Political Science at Texas Tech. Dr. Hayhoe is the author of the book, Saving Us, a Climate Scientist's Case for Hope and Healing in a Divided World. She has given a TED Talk with over 4 million views, and she also hosts the PBS digital series, Global Weirding. Dr. Hayhoe has been named one of Time's 100 most influential people, the United Nations Champion of the Environment, and the World Evangelical Alliance's Climate Ambassador. Dr. Hayhoe.
Thank you so much. It is great to be here. So I am in the Department of Political Science and the Climate Center. And a year ago, though, I actually moved to the DFW area where you might have heard Texas opening a new campus in Irving. It just opened 3 weeks ago. And public administration, the program I'm in, is one of the programs that's going to be offering classes there. So it's great to be back here. This is my first time back this semester. I can't believe it. It's already at the end of the semester. And this is going to be a somewhat unusual seminar because what I loved about this is that you sent me a number of questions you wanted me to answer. And I thought of a few more questions that I can answer that you might be interested in. But by the time I got finished with answering the questions, it was a 3-hour course. And I know you all have other plans, right? Or maybe not. So what we're going to do is, I always like using interactive polling software, so I'm going to start with that anyways, but I'm going to do something I've never done before, which is I'm going to be asking you what questions you want me to answer. And I have prepared answers to 10 different questions. And I think we'll probably get through maybe 4 or 5 of them, maybe 6 or 7, depending on which ones you choose. But I just want to make sure that I'm answering the ones that you want me to. So I am a climate scientist. I study how climate has changed and how it will continue to change in the future. But what I do is I work at the intersection of climate and impacts. So I work with economists and ecologists. I work with medical professionals. I work with engineers and agricultural specialists. I even work with, well, for example, my next talk is going to be to the National Ski Association because they're understandably very worried about climate change and skiing. So I work at the intersection of all of these different fields because I'm convinced that climate change is already affecting all of us. Every sector is being affected. And if we don't think we're being affected, it's just because we haven't connected the dots. So I've spoken to people who are in emergency response and emergency management. They're being affected. I've even spoken to people who work in the digital world, and they've told me how their resources, their data centers, their power is also being affected by extreme disasters that are being made worse by climate change. This past year, I've spoken to the Harvard Medical School, and I learned a lot of things from them about how climate change is affecting children and maternal health and the rest of us as well. So this really covers the gamut. And so what I'm doing here is I am focusing on agriculture. Those are all the related questions. So if you have any questions about skiing, you're going to have to save those for next week. But on agriculture, there's a lot that we can explore. And on climate in general, there's a lot that we can explore. So I'm going to ask you to do something that's a little bit unusual. I'm going to ask you to take out your phone. I know, turn the ringer off if it isn't already off. Go ahead and take out your phone, or if you have a computer, you can do it on the computer as well. If you're listening online, you can do this online. So we have 7 people online, and actually, let me just say hi to everybody online. Okay, I am here. I turned the video off though, because the camera is going to be pointing at the side of my head most of the time. So this is the only time that I'm saying hi in person to the people online, but hopefully you can still hear us and see us, and you can participate in this. So once you've done that, if the QR code isn't working, you can type in that address, polev.com/Katharine, but it always trips people up because Katharine has 2 A's. And I was saying that I have a couple of colleagues who also spell it that way. And I was saying that to them, and they said, yeah, when I went to Starbucks, I told them Katharine was 2 A's, and I picked up my cup and it said Katharine. So when I go to Starbucks and they ask me my name, I just say Anne. It is my middle name. All right. So if you, anybody still waiting? Okay, everybody's got it. All right. So the first question I have is for you, which is, who are you? And a bunch of you have already answered. So faculty, staff, grad student, postdoc, undergrad, or other. So it looks like we have very high attendance from graduate students and postdocs, which is always what we want from our seminars. Thank you. By the way, I still remember some of the seminars that I went to when I was a graduate student, because it was such a tremendous opportunity to hear from faculty at different universities what they were working on. So 71% grad students and postdocs, 29% staff and faculty, and yeah, that's everybody. All right. Now I will note, if anybody's listening to the recording, you can't do this if it's recorded only live. That's why you always want to show up live. All right. Next question. Now, this one's a tricky one because you have to answer with no spaces. So if your answer is soil science, you have to not put a space there to say soil science. Or biological sciences, you can just say biology, or political science. And the reason for that, you can see, is because this is a word order. And the more people answer, the bigger the word. So this shows me who you are. Somebody didn't listen. I think it might be Michael, applied economics. There you go. Okay.
We're
so
still linking over here.
Yeah, no worries, no worries. We're all among friends. That's why I feel free to call people out. I normally would not do that. All right, plant and soil science is biggest, and we got PSS there too. Okay, we got ag, civil engineering, biology is pretty big there too. Excellent. Okay, so now you know how this works. So now we're going to get to the meat. Here are the questions that I was asked to answer. And there's some variations on them. I have answers to too. So questions you asked and a few I added. I want you to vote. Which one are you most interested in? Why does climate and climate change matter? Why does anybody care about it? Number one. What's causing it and how do we know what's causing it? Number two. What's new in climate science today? If you've always wondered that, I'm here to answer your question. I can absolutely tell you what's new. How is agriculture contributing to climate change? Now, this is an interesting one, number D, because I will say that my answer there might surprise you slightly. I see that it's going to go falling down. It might surprise you slightly. How is agriculture affected by climate change? How is it being impacted? And the answer is in many ways. Now, this was an interesting one. I'm really glad you asked me this because I love this question. What do people think about it? So I will tell you a little factoid. It turns out that across the US, people think they care, but nobody else cares. People think they're doing something about it, but they don't think anybody else is doing something about it. And so because we always underestimate what other people think, there's less support for positive solutions, which is the last one. And that's why having conversations is so important, because that way we figure out what other people think. And that's why looking at the data is so important. I like looking at the data too, so I have a lot of interesting data there. So we've got, how can agriculture be part of the solution? Wow, that is a solid vote there. That is very solid vote. Okay. So based on your results here, and I should note that as we go along, I'm going to leave this up. And anytime you have a question, you can put your question in here and everybody else can look at the questions and they can upvote the questions they most like. So we'll have some time for this too. So this is going to be open for all the time. Whenever you have a question, you can put it in here and we'll go back to it and look at it once in a while. But it looks like we have some pretty strong consensus here. What's new, number one? And then we could touch lightly on how agriculture is contributing. We'll just touch lightly on it because I do have something interesting to say there. Then we'll go to what people think about it. I really like that. It's very interesting. And then we will end solidly on what can agriculture do for solution. Great. Thank you. Okay. So now I'm just going to have to skip ahead here. So pardon me. I don't know any fancy. I have the small computer, not the big one. You know, if you have the big one, it has like a little window. You can see all your slides and you can go ahead. I've got the small one. So I'm going to have to go out of presentation mode and jump to what's new. And then jump back in. All right. Here we go. What's new today? I'm going to actually start here. There we go. All right. And let's just look at the chat to make sure that we don't have anything. Oh, it's very difficult to hear. Could I please adjust the audio? I'm sorry that the computer is not so close. Maybe if I go like this, let's see. If I go like this, these cords are very short. Hopefully this will be a little bit better because now I'm next to the computer. Okay, that should be better. All right. So this is where I wanted to start because people often think that we're just starting to figure out this whole climate change thing. I often hear from people who say sort of skeptically, especially around here, well, it wasn't until Al Gore made that movie that you scientists started to study this. And I'm like, well, where do you think he got the information, the graphs he put in his movie? You've never seen a movie with more graphs than you have the inconvenient truth. So the reality is that we've known about this problem for a really long time. In the 1820s, Joseph Fourier, and if those of you, if you're in math or statistics, you've heard of a lot of these scientists. Joseph Fourier figured out that the Earth should be a frozen ball of ice. The Earth should be 30 degrees Celsius cooler than it is today. The average temperature of the Earth is about 15 degrees Celsius. So it should be freezing, but it isn't. And so the reason it isn't is because we have an atmosphere, he figured out, that keeps us at just the perfect temperature for life. Fast forward to the 1850s and the 1850s also, John Tyndall in Ireland, who was a very distinguished scientist, part of the Royal Society, he was doing some experiments showing that methane and carbon dioxide were two of the gases in the atmosphere that were trapping heat, like a blanket, causing the Earth to stay at a nice temperature for life. But on the other side of the ocean, Eunice Foote was an amateur scientist. Why was she amateur? Because it was really hard for a woman to go to university in those days. In 1856, she was conducting experiments in her backyard with glass tubes, breathing into them to put CO2 into the glass tubes. And she determined that if CO2 in the atmosphere were higher, the planet would be warmer. And she even calculated how much warmer. Her observations were reanalyzed by two climate scientists 5 years ago. And they found that she had made the observations that would have allowed her to calculate climate sensitivity, which is how sensitive the planet is to human emissions of carbon. She made the calculations, and they calculated based on her handwritten notes that had been preserved, and it was almost exactly the same as the median value today. Is that not amazing? She was also a women's rights activist, and she attended the Seneca Falls conference. The reason why there's not a real photograph of her is because we can't find one. So I and Liz Foote, who is obviously a relation, who's a marine biologist, we have been combing archives for 5 years looking for a photo of Eunice. I have gone through the Smithsonian archives. I've written to the Washington, D.C. Historical Society. I've written to the Seneca Falls National Park. I got on Ancestry.com and I actually tracked down her relatives that are still living today. And they were, first of all, very surprised to hear what their great-great-grandmother did. They didn't even know. And they didn't have any photos of her either. So she remains like this. If you Google it, you will find some things Google say are her photo, but they're actually of her daughter. And then there's one that is unidentified. But she actually said how much warmer we would be. And then by the 1890s, Svante Arrhenius is a Swedish scientist. And in between doing his Nobel Prize winning work in physical chemistry, he had to do something on the weekends, because what else do scientists do on the weekends other than science? So he decided to calculate the first climate model by hand. And it took him 2 years. And he calculated for each latitude band of the Earth how much it would warm if carbon dioxide increased by 50%, or it doubled, or it tripled. And the numbers he got are exactly the numbers that we get today. Halfway through his calculations, his wife packed up the family and left. Yes, you can sort of see why. But interestingly, he is also a distant cousin of Greta Thunberg, you know, the young woman who's a climate activist. Now, in Sweden, it could be that everybody's a distant cousin. But her father's mother's last name was, no, his mother's name was Thunberg. That's the relationship. And then lastly, we get to Guy Callender, who's a British engineer. And for his entertainment on the weekends, because what else do engineers do? He rode around the world and collected weather station data from all of the weather stations around the world, many of which the British had put up in their colonies. One positive benefit of colonization, one. And from that, he determined in 1937 that the planet was already warming. Not that it would, but that it was already warming because of emissions of what he called carbonic acid, which today we call carbon dioxide. So I wanted to start with this because this is what is not new. And really, so much is not new that by the 1960s, scientists knew enough to formally warn a US president of the dangers of climate change in the 1960s. So when I say what's new, I want to be very clear that I'm not talking about what's new in terms of, oh, now we know enough that we need to do something about it. We knew that in the 1960s. What do we know now? Well, first of all, we know that our carbon emissions from burning coal and gas and oil have increased exponentially. Look at 1880 and 1890. That's when Svante Arrhenius was doing his work. He actually thought that these emissions would increase linearly. And so he thought it would take centuries to get to where we are today. Because he was a chemist, he wasn't an economist. Today, we know that 78% of all of our heat trapping gases come from fossil fuel burning and from industry. We also know that about 22% come from deforestation and agriculture. Hold that thought, because we're going to get into that a little bit more in the answer to the question about how does agriculture contribute. And since then, these heat trapping or greenhouse gas emissions have become embedded in nearly every sector of the economy. Electricity, heat production, agriculture, forestry, land use, buildings, transportation, industry. I mean, what do we do that doesn't involve energy? You might say, I go for a hike. How do you get there? I go for a paddle. Again, how was the kayak made? I go for a walk. Where did your shoes come from and how did you get them? You see what I mean? Energy is part of every aspect of our lives. And the fact that we get most of it, or at least in the past, we have gotten most of it from fossil fuels, has led to it being embedded in every sector of our economy. Now, I don't know if you saw the news, but this year, so when I joined Texas Tech 15 years ago, the state of Texas was already #1 in wind energy production. Last year, Texas passed California for the most installed utility scale solar in the country. Texas wasn't even top 10 15 years ago. And on the weekends, a lot of the weekends lately, over 70% of the electricity on the Texas grid has been wind or solar. Isn't that interesting? Texas is also a leader in battery storage. It's a leader in geological storage, and it's a leader in geothermal energy, which is the next frontier of clean energy. And in fact, many oil and gas workers who know how to drill, they're now drilling for heat rather than drilling for fossil fuels. Anyway, interesting note about Texas. So like I said, since then, scientists formally warned a US president, and it says 50 years ago, but that title was almost 10 years ago, 1965. And now we know that we're seeing the impacts. So, you know, you could smoke a pack of cigarettes a day for a month, a year, and you might not notice anything. But one day you're out for a jog and you start to wheeze. That's where we're at now. We're out for a jog and we're starting to wheeze. The impact of all of the carbon that we've been burning is now being observed, and it's faster than any time in human history. And that's why this matters. The planet's been warmer before, it's been cooler before, it's never had 8 billion people on it before, and it's never seen climate change this fast before without triggering an extinction. That's happened 5 times, and we don't want it to happen a 6th. What else we know is that the subsidies to the fossil fuel industry have reached record highs. They amount to almost $1,000 per person at the global scale. So we are actively subsidizing. This is from the IMF, is the International Monetary Fund. So this is not a Greenpeace slide. This is not an environmental organization. This is the International Monetary Fund. And they're saying scaling back subsidies would reduce air pollution, generate revenue, and make a major contribution to slowing climate change. In fact, subsequent analyses have showed that the faster we transition to clean energy, the more money we'll save, at least $12 trillion globally by 2050. And then, where are we now? We know that last year was the warmest year on record, and it broke thousands of sea surface temperature records, ocean temperature records, stream temperature records, daily heat temperature records, all around the world. So one question that you'll hear scientists arguing right now is climate change speeding up? And I feel like, why even argue about this? Why even argue? Because unless, these are the old scenarios that we worked with up until 10 years ago, and these are the new scenarios that we work with now, unless we significantly reduce our emissions, it's always going to speed up. The black line is a linear trend based on 2000 to 2015. That's what the black line is. The only scenario under which warming does not accelerate is if we've taken very significant action. And so far we've taken some, but not enough. So why wouldn't it accelerate? So when you see scientists arguing, is it happening faster or not? I'm not on one side or the other. I'm just like, we know it's gonna. The question is just, have we detected it? So why waste time? We know it's going to speed up unless we do something significant. And then another question people often ask is, are weather extremes getting worse? And the answer to that is yes, this is something else that we know today. We know that wherever we live, we get weather extremes. We know that that's a key part of agriculture and agricultural planning and crop insurance. But we know that climate change is loading the weather dice against us. In other words, the chances of rolling a severe heat wave or a drought are greater. When a wildfire starts, and in the lower 48 states, what's the #1 reason a wildfire starts? Accidental human ignition. In the case of the wildfire we had in January up by Amarillo, power lines sparking. Believe you me, the power company didn't want that to happen. That was definitely an accident. But once it starts, it burns larger area because there's drier fuel, drier soils, less rain, warmer conditions. And it was very warm during those conditions in January. We know that hurricanes and cyclones and typhoons occur naturally, but they're powered by warm ocean water. And the warmer the ocean gets, the more energy is available for that storm to spin up into a much stronger storm than it would be otherwise. So 10 years ago, when I would get a call from a reporter and they would say, you know, Lubbock, Texas just recorded the longest dry spell in history. Is this climate change or not? Like they would be wanting a yes or no answer. And every climate scientist had the same answer. We cannot attribute any individual event to human-caused climate change, but over climate timescales of 20 to 30 years, we know that, and then insert the answer for drought. In the case of drought, we know that droughts are getting longer and stronger. So in this part of the world, droughts are initiated by natural variability, predominantly El Nino and La Nina. They're initiated by natural variability, but the length and intensity is moderated by a change in climate. In fact, I have 3 papers showing that, specifically for Texas. So this is what we could say 10 years ago. But 10 years ago, we didn't have nearly the extreme events that we have today. In the US back in the 1980s, there was $1 billion climate and weather disaster on average every 4 months. That's 3 a year. Accounting for how the value of the dollar changes over time, but also recognizing we have more infrastructure now. Now, let's see, there we go. We have one every 2.8 weeks in the 2010s, and last year we had one every 1.8 weeks in the US. So every week last year, just about, there was a disaster in the headlines from somewhere in the world, and every other week that disaster was in the US on average. So now our science has significantly advanced. The field of attribution is one of the fields that's changed the most in the past 10 years. Attribution is, can we put a number on one specific event? And the answer is increasingly yes. We can say that the floods they experienced in Germany in June 2021 were 9 times more likely. In other words, if you're rolling the dice, you're 9 times more likely to get those floods today compared to 100 years ago. With Hurricane Harvey, we were able to go farther. We could determine how much more rain fell, how much more area flooded, and then even how many more dollars of damage occurred. The total damages directly were about 120 billion. And over half of that was because the hurricane was stronger and bigger than it would have been 100 years ago. Would Hurricane Harvey still have occurred if it weren't for climate change? Yes. Would it have been as strong and as damaging? No. Now, this past May, scientists went even farther. They looked at the area burned by wildfires across the Western US since the 1980s, and then they looked at how much carbon is produced by each major fossil fuel company. Take Shell, for example. They've produced more carbon emissions than the country of Canada in their history. And they found that 88 companies are responsible for 37% of the area burned across the Western US. Now, in my mind, this is where the lawyers start to perk up and get interested. I haven't seen that happening yet, but I feel like it's coming. And so there's this great organization called the World Weather Attribution, headed by one of my colleagues, Freddie Otto at University College London. And World Weather Attribution does this rapid attribution on events that are happening now. And one of the events they looked at recently really caught my eye. It is the massive drought that they are currently experiencing across some of the poorest areas of Syria and areas of Iraq and Iran. And what they showed, if you look at the right-hand side here, is that it wouldn't even be a drought without the amount, 1.2 degrees Celsius of warming that we've experienced already. So without human-induced warming, it would be the bar on the left. With current human-induced warming, it is an extreme drought. And if we have 2 degrees Celsius of warming, that would get into an exceptional drought. So this is actually showing that that drought wouldn't have been a drought. The precipitation deficit wouldn't have been enough to be categorized as a drought if it weren't for all the extra heat pushing it up. This is what's new. All right. So this was one of the ones that got a few votes, and I just want to touch on this one because I think it's really interesting. So emissions from agriculture come from a lot of different places. Agriculture is a very complex sector, and the emissions are of different gases. What do you see here? You see carbon dioxide, CO2. You see methane, CH4. You see N2O, nitrous oxide, and you see them coming from multiple different sources, including livestock, they're burping, manure management, soil management, rice cultivation, fertilization, burning fields, something that happens often at the Nature Conservancy. We have a project in India specifically to try to prevent field burning, all the fuel and energy people use to farm, on-farm electricity use. Then you've got land conversion going on, and then you've got ways to actually suck some of it back into the soil and into the ecosystem. So this is complex. Because it's complex, these numbers I showed you here, especially the numbers at the bottom, are a very active area of study. Very active. And in fact, this actually belongs in the what's new category, in my opinion. So a couple of years ago, a number of my colleagues at the University of Illinois, my PhD is from Illinois, and the last author here was actually on my dissertation committee. A number of my colleagues at University of Illinois did a really exhaustive study where they found that when you look at all of the emissions across the whole food sector, so not just agriculture, but transportation of food, use of food, food waste, all the food, it's actually a third. And they compared animal-based foods to plant-based foods. And I'll just highlight a couple of the results for you. They found that food-based agriculture accounts for 35%. Plant-based food is 29% of the 35, to be clear. And then animal-based food is 57% of the 35. If I were an author, I think I would have clarified this a little bit. It's a bit confusing, isn't it? Like you could read this and take it as 29% of all our emissions are plant-based food. It's 29% of 35. There you go. See? So I think that if something's important, you should spell it out. So that's why I'm spelling it out here. And you can see that it's got 32% methane, 32% carbon, 20% methane, 6% nitrous oxide. But here's the thing is, how you balance the different gases depends on the time horizon. Over 20 years, methane is 85 times stronger than CO2. But over 100 years, it's just 37 times stronger. That was actually my master's thesis. I was calculating the indirect impacts of methane on atmospheric chemistry to figure out what its global warming potential was, which is what we call these numbers. So even that depends on the time frame you're looking at. Although carbon dioxide is the most important and frequently discussed greenhouse gas emissions, methane and nitrous oxide are, and these numbers here are the 100-year numbers. Oh, sorry, I said 37. 34 and 298 times more powerful when it comes to trapping heat in the atmosphere, said Xiaoming Xu. And interestingly, this was really interesting. They showed that the countries with the leading emissions from animal-based food are China, Brazil, the US, and India. And countries with leading emissions from plant-based food, mostly rice, flooded rice paddies due to anaerobic digestion of under the flooded area. They're big producers of methane. Plant-based foods are China, India, and Indonesia. So I thought that was really interesting. If you look at the US is, the agricultural is a bit smaller. They call it, the official numbers they call it are 11%. But, and you can see actually they've got half of it as N2O. But then I want to show you this other really interesting study that just came out a year ago. They found that food waste is, and they found half of it, but the total they were working with was smaller than the previous paper. So if I had to modify this, I would actually say 40%. If I combine the two papers, I wouldn't say half. But I was surprised. I was actually surprised by this number. I would have guessed 20 to 25% food waste. But it's likely probably about 40%. And so what they found, FLW here is food waste. Global food waste, the sources are widely distributed across 9 post-farming stages and vary according to country, region, and food category. Income level, technology availability, and prevailing dietary patterns affect emissions. The biggest difference is between high-income and low-income countries. In high-income countries, the biggest source of our food waste is because we don't like how it looks, or we buy too much and we throw it out. That is the #1 source of our food waste, and almost half the food in North America is wasted because we don't like how it looks, or we ordered a giant plate. Speaking as a Canadian, I will say that growing up, there was just a running joke among Canadians about the serving sizes in the US. Like literally our cans of soda were smaller in Canada. You don't get free refills on sugary drinks. The plate sizes were half. And then we'd all go to Florida for spring break and you go to one of those buffets. There were no all-you-can-eat buffets when I was growing up. So the relationship we have with food culturally can lead to a lot of food waste. And of course, you know, there's a whole movement towards ugly food now where you can order ugly food that just doesn't look quite right and get it at half price, but you're reducing food waste. What's the #1 source of food waste in low-income countries? Spoilage. They can't get it to market. They don't have refrigeration abilities. And so people are going hungry when 40% of the food has gone rotten before it can get eaten because they can't get it to the people who need it. So one of the boards I serve on is for an organization called King Philanthropies that aims to combat poverty and climate. And what they try to do is really cool. They invest in potential businesses that can't make money yet, but they think they might be able to in the future. And one of the businesses they've invested in is a company that figured out how to create a sticker that you put on fruit, and it extends the lifetime of the fruit by, I forget, something like a week or more without going bad because of the chemicals and enzymes in the sticker. And then there's another company that's creating a spray. I mean, imagine how that could revolutionize food waste. All right, so that was why I thought it was interesting and worth talking about. Now let's go back to your questions. Where were we in terms of the votes? We are, and don't forget, you can put your own questions in too. Anybody can do this online or in person. So we are at, we talked about what's new. We talked about how ag is contributing to climate change. Now we're going to go to what people think about it and then how ag can be part of the solution. And at the end, we'll save a bit of time for here. The geothermal energy comes from deep down in the Earth's crust. The further down you go, the warmer it is. It's really cool. And there's so much of it that it's basically infinite for our purposes. And the deeper you go, the hotter it is. Okay, so now we're going to jump to what do people think about it, and then how can ag be part of the solution? Excuse the jumping again here. Now, this part is fun because I really enjoy looking at what people think. So remember I talked about extreme weather? So the first question I want to answer is, are people, I'm going to talk about people first, then I'm going to talk about farmers next. And you'll see there's a lot of similarities. But just looking at people first, are people noticing that the weather is getting weirder? The answer is yes. A survey last September, based on, reported in September, based on April, found that, April to September, 55 to 74% last year had experienced extremely hot weather or heat waves. 42 to 45 had experienced severe storms in the winter. 30 to 32, major droughts or water shortages. 24 to 31, hurricanes or severe storms, flooding, wildfires, tornadoes, and other severe disasters. Interestingly, when people across the US were asked what's the greatest threat, weather extremes was number one. Number two was nothing, which means we have some work to do. But number one was weather extremes, which I would agree with. Are people hearing enough about it? Well, it turns out the answer is no. Coverage of this issue has dropped. And you might say, well, hang on, you just told us it was the warmest year on record last year. There was a disaster every week somewhere around the world, every 2 weeks in the US. How did coverage drop? If we knew the answer to that, you could probably get a really good PhD thesis out of it. I think it's related to people just tuning out because you can only take so much bad news if you don't talk about what 58% of you voted for, which is the solutions. And most of the news doesn't talk about solutions. 90 to 95% of the news doesn't talk about it. And the 5% that does is typically journalists that I've lectured. I've actually been personally lecturing people in a nice way, usually over coffee, over how we need solution stories. Otherwise, why tell people it's bad if we can't fix it? The percentage of people who hear about it in the media at least once a week. Anything blue is less than 50%. This is pretty dark blue. People around the world who hear about it at least once a week. The countries that are most vulnerable hear about it the least. I was talking to a colleague in Indonesia, and she said, we don't hear anything about how it's affecting us in Indonesia. The only thing we hear is from the American media. Well, Indonesia is so vulnerable that sea level rise is one of, not the only, but one of the primary driving factors for them picking up and moving their entire capital city. You're moving the entire capital city and nobody's talking about climate change. Wild. Yeah, two of the most vulnerable forests in the world, which will have tremendous biodiversity impacts and tremendous local climate impacts also. So what do Texans think about climate change? The Yale program on climate communication just updated their maps last year. And these are maps by county, but you can also get them by congressional district. And what they say is that most people agree it's happening. Now, okay, Amarillo's not as big as Lubbock. Why is Amarillo on these maps and Lubbock is not? I think we'll have to have a conversation with somebody about that. Anyways, I highlighted Lubbock County in a couple of these just so you can see where Lubbock County is. Now, about the same number agree that global warming will harm plants and animals. They didn't ask specifically about farming, but they asked about plants and animals, which is farming, if you're a farmer. Do you think it's affecting the weather? We start to see a lot of blue showing up, and in Lubbock County, we are at 56%, and we're higher than our surrounding area. Well, this is not an opinion. This is a fact, and I can tell you the answer is yes. I can tell you, if you've lived in Lubbock for 10 years, I can tell you 10 ways extreme weather has affected the conditions here in Lubbock. Now, here's where it gets interesting. Did you know that we are experiencing very rapid inflation at this moment in the US and around the world, and including in the price of food, and the massive increase in fossil fuel prices are one of, not only, but one of the primary drivers? Nobody knows this, and so we don't think any of this affects us personally. Oh, did you know also, I don't know if you've seen the headlines, home insurance rates in Texas. Anybody seen any headlines on that recently? If you don't own a home yet, you're lucky, because believe me, you have something coming. Depending on where you live, our home insurance rates are going up 50% or even doubling in a single year. And I just read a really good article in the Texas Tribune a couple of weeks ago, and they asked all the insurance companies why, and the insurance company said, because Texas has more billion-dollar weather and climate disasters than any other state, and climate change is making it worse. And then they asked the state official why, and he said, well, we don't know. And I was like, just read the article. Insurance people are telling you why. Our HOA fees just went up 70%. And I don't know if you're part of an HOA, but you know, the email chain started going. Everybody was, upset. So I looked at the attachment, I looked at the breakout, I realized 50% of the 70% was our homeowners insurance going up. So I took the Texas Tribune article, I just replied all to that. And that was the last I heard. Because what can we do? We have to take it up with the insurance companies. And you know what they're doing in Florida and California and Louisiana? They're saying, oh, you don't want to pay it? Well, fine, we won't offer it in your county. They're pulling out. I was on a panel in January with the head of a big investment company, with the head of the United Nations Environmental Program, with an economist, and with the head of a big reinsurance company. And I went down the row asking each one of them, are we adapting quickly enough to climate change? UNIP said no. The investment company said no. The economist said no. The reinsurance CEO said, oh, yes. And I said, tell me more. And he said, well, we just price insurance each year. So we just price it at what would enable us to actually, profit from it. And if we can't offer it somewhere, we just pull out. So what they're doing is their adaptation strategy is actually making everybody else less adapted. Because if you don't have insurance, then you can't pay for the damages that are happening to your home, your infrastructure, your crops, et cetera. So this is a factual, yes, it is already. In fact, you know what? I would answer no, because I would say it's not will, it's is already. I don't think that's why most people answered no. Have you personally experienced it? The answer here is yes, you have. If you live in Lubbock, you have. But only 42% would agree. And this is a big part of it. Look at that. If you don't talk about it, why would you understand what's happening? So 10 years ago, I was standing in line at my church, just down the south end of town, waiting to pick up my son from Sunday school. And the guy behind me said, do you mind if I ask you a question? And he kind of whispered. I was like, well, sure, it's fine. We're just standing here. And he said, do you think the weather has gotten weirder? And I said, oh, yes. So I went through our heat waves, our droughts, our heavy rain events, like record dry conditions, then the football stadium's underwater, right? And all the undergraduates are driving down the Marcia Sharp into the puddle of water, and they have to be, or not the puddle, into the, feet of water, and they have to be pulled out. And so I told him all about it. And he got more and more excited. He's like, yes, I knew it. I've lived here for so long. I've seen things happening. I knew the weather was getting weirder. he was excited to just have the conversation and validate his opinion. So when I have conversations now, I don't tell people, I ask them. I say, can you tell me how the weather's gotten weirder? And here in Lubbock, 9 out of 10 people are full of stories to share about how it's gotten weirder. Now, let's get to some interesting things. Look at this. Most people support generating renewable energy. Now, they didn't ask on private land, but I would bet it would be basically dark red brown if you could personally profit off it. Some people say that they claim that wind turbines generate some type of wind turbine syndrome. I don't know if you've heard that. They say like the blades rotating cause some type of syndrome. So they did an exhaustive study in Australia where they have a lot of wind, just like us. And they found there was one factor, only one, that predicted whether people had or reported symptoms of wind turbine syndrome. That one factor was whether or not they were financially benefiting from the wind turbines they could see. If they were on their neighbor's land and not theirs, versus if they were on their own land. So most people would support this. Now, this is interesting. Should schools teach about the causes, consequences, and potential solutions to global warming? My classes at Tech are open to students from any department. I have a grad class that I'm teaching this fall, and an undergrad class I teach in the spring, and I make them open to any students because they're the only classes that address this topic at our campus. Now, on the Climate Center website, we have a list, and you're probably going to be updating it, of all the classes that include something about it. There's, I think, over 50 classes that include something, and they should, because we can include in all kinds of classes. But this is why I offer the classes I do. This is an interesting one. Do you think the governor should do more? Do you think our local officials should do more? And then now let's get to farmers. What do farmers think about it? So there was an interesting report that came out 2 years ago on young farmers. That's the next generation. 86% identify the practices they use as regenerative, and 97% identify them as sustainable. Isn't that interesting? 83% said that one of the main reasons they have a farm is to engage in conservation. 29% of young farmers, 74% of Black farmers said that they were actually working to make their work less racist and to promote healing from white supremacy, which is also very interesting in this sector. Now, getting to the impacts. 73% have experienced at least one impact. In the last year, 88% attribute them to climate change. So young farmers are a lot more in touch than the average person. This is a study where they specifically looked at Iowa. For some reason, most of the surveys are for Iowa. What's with Texas? There's a lot that you could do surveying people in Texas. A lot of the data is for Iowa, but it's not that different from Texas. They found that people's attitudes varied with trust in the sources, the groups they were hearing from. And support for doing something about it varied with how risky they thought it was. So they have this Iowa Farm and Rural Life poll. Has anybody seen this? Nobody? Okay. So in 2023, they compared, is climate change happening due mostly to human causes? And they compared it with 2011, 2013, and 2020. What do you see is happening? The brownish area grew, and then it's, there's a bit of variability there. But the farmers' opinions are moving in a certain direction, right? They're moving in the direction of saying, yes, this is real. And in 2020, the third bar, they went into more depth. So I'm going to show you more depth for 2020, questions they didn't ask last year. Are extreme weather events going to be more frequent? So here we have 2011, 2013, and 2020. Yes. Are you concerned about the impact? Woo, that went from 35 to 51 in 9 years. Will crop insurance protect you? Oh, that's going down. Will human ingenuity prevail? Oh, big dive there too. Isn't this interesting? So farmers see the changes that are happening. What should seed companies do? What should university extension programs do? What should state agencies do? These numbers are pretty consistent. They feel seed companies have a big role. Extension agencies, obviously, our university has that. We have a role. They feel state agencies should be doing more. And then, should the government be doing more to actually fix this problem? This is pretty interesting because whose problem do they think it is? Clearly, the government should be fixing it, is the attitude of farmers. So I don't know if you're familiar with the analysis that Bayer does. And they put out their latest one in 2023, where they found that in 8 different countries, 70% of farmers had already seen impacts. So I want to highlight a few things here. Now, the 8 countries they look at are Australia, Brazil, China, Germany, India, Kenya, Ukraine, which is a very interesting one from a farming perspective right now, and the US. And what they found is that 90% of farmers say the weather's changed. Remember, we looked at people and then farmers. Farmers are way more in touch with whether the weather has changed. But like most people, they highlighted heat first. High temperatures, long periods of high temperatures, drought was next, and then changes from one extreme to another, and the change in the date when the season starts or ends. 16% had experienced income losses in the last 2 years. 1 in 6 identified income losses over 25%, and 76% are worried about the impact it will have on their farm. I think these quotes are interesting. Sometimes I feel like quitting because of the loss brought by climate change. Farmers are adapting using new technology. 73% have seen a rise in pest and disease pressure over the last 3 years, but now they're using technology so that a plant can talk to the farmer, right, and tell it which plants have which diseases. So you don't have to apply the fungicide or the herbicide over the whole field. You just apply it to the corner where the plants are reporting what it has. So there's some really interesting advances. More resilient crops, different crops, increased pressure from pests, increased crop failure are the uncertainties they're coping with. And they see a role for digital applications, imagery, predictions. There's a lot of technological resources. I had a really interesting conversation right after the one I had with the panel I told you about, with a guy who runs an ag company in Africa, and they have a mobile app that gives farmers all the information they need at their fingertips that they never would have had a way to get before. We were talking to him about incorporating climate projections into what he was doing. Preserving the environment is important, but 88% say they want to be compensated for it. And cover crops is one of the biggest ways. Cover crops, renewable energy, innovative seeds, digital tools. And farmers are also planning to help with biodiversity. I love this one that the India woman said. She said, if we cannot save our soil, don't you love that term? If we cannot save our soil, that will affect food security for many people. And then I wanted to end with highlighting the fact that what we see here is very different in other places, because this study in Saudi Arabia, for example, farmers were concerned, but what was their main issue? Lack of knowledge. So the ones who are most concerned and most vulnerable are the ones who have the least information. All right, let's end by talking about solutions. What do solutions look like? So when it comes to agricultural solutions, I think it's important to highlight how there's no silver bullet, but there's a lot of silver buckshot. In other words, there's no one solution that will work for everything. If you think of the atmosphere like a swimming pool, and the level of water in the pool is the heat trapping gases in the atmosphere, the hose are our emissions. We have to turn off the hose. Agriculture is a big source of emissions. Efficiency, clean energy, smart agricultural practices, behavioral change, these are all ways that we can turn off the hose. But our hose also has a drain. And if we can make the drain bigger, we can take carbon out of the atmosphere. And a lot of smart agricultural practices can do that. It's not only about protecting, restoring, and regenerating ecosystems, it's also about climate smart agriculture. This is where the term net zero comes from. What's coming out the hose equals what's going down the drain. But there's one more thing, and that is the fact that the water in our pool is so high, our toes can't touch the ground. We have to learn how to swim. That's adaptation and resilience. That's using technology, infrastructure, ecosystems, social adaptation, like digital tools for farmers. That's what resilience looks like. So there isn't any one category. We have to do all three of these categories. And Project Drawdown is a great resource. If you're not familiar with Project Drawdown, I really like them because they are a library of solutions. So if you go to the agricultural sector, they have a short article with the potential for each of these solutions on each ag-related solution. Nutrient management, regenerative agricultural cropping. It turns out that that dragging the ocean floor when fishing creates a ton of carbon emissions. So that's why seafloor protection is there. Conservation agriculture, irrigation efficiency, improved cattle feed. Cactus Feeders up in Amarillo is experimenting with, can you help cows' digestion by feeding them probiotics and other supplements so they don't burp as much methane? And would they produce more milk or more meat? There's a lot of different solutions we can look at. Cutting the methane, capturing and burning the methane from the manure. Cutting the nitrous oxide emissions from fertilizers. Capturing the carbon and turning it into biochar by burning the agricultural waste at high temperature, putting the biochar back into the ground where it's a fertilizer. You might recognize someone here. She's sitting right here in the front row. A number of years ago, before the pandemic, the Smithsonian Natural History Museum was putting together a brand new exhibit, and they wanted something about how we do carbon farming here in West Texas. So they worked with Natasha and with, is it Aaron Hopper in there? Aaron Hopper, one of our extension farmers, to document the practices he was using. So when it comes to solutions, there's no silver bullet, but there's so much good stuff that works that you can find something that fits just about every person. And this is a great place to end because this is what we're doing right here at Texas Tech, right? We're working with people in the real world to look at how we can make a difference. And that's really, I think, what informed and engaged scholarship is all about. So thank you very much. And before I go, we'll just take a quick look to see if there's any more here. If anybody has to run, that's totally fine, but we'll answer any quick questions that remain. Let's see, any, oh, no, people have been very sparse with the questions. All right, let me tell you then, just in case you have a question later, because sometimes that happens, right? Like you're, walking down the street and you're like, I have a question, why didn't I ask it? Tomorrow night, I'm going to be doing Science by the Glass, which is part of our Texas Tech Climate Center program at First Friday Art Trail, and you're invited. So if you'd like to come along, I'm going to be talking at 6 o'clock and 7:30 at the Nashville Cafe, where you can get snacks and drinks and food. It's on the First Friday Art Trail. And you're welcome to stop by and ask me a question that you didn't ask today. One more thing, since you have your phones out, if you want to know more about what I do, I have a newsletter every week. Good news, not so good news, and something we can do. I talk a lot about food. I talk a lot about natural climate solutions. I have guest editors like our plant prof over there, who I asked to give me good news, not so good news, and something you can do about it. Wave so everybody can see you. There we go. Yes. So if you want more info on climate with a side of food and agriculture, I encourage you to do that. But otherwise, I would love to see you tomorrow night if you want any more questions, and you can invite anybody you want. Thank you.
Can we get a copy of the slides?
I think this has been recorded. Is that right? Yes. Yes, I can do that. And then what I do with my slides is I always annotate them with the sources. As an academic, I can never just give things that aren't properly referenced. So what I'll do is I'll annotate the sources and then share them with the PowerPoint.
Dr. Hayhoe, first let me congratulate you on your American Academy of Arts and Science first member. So I'm from toxicology, so when I work in cotton, one of the things is all these talks are good, but when it comes to reality, where the rubber meets the road, when the prices are, I'm talking about non-food, cotton is non-food, but that's base of the economy here. So So all these are good, but where the rubber meets the road is the cost. When the price demand is not there, prices are highly volatile. When the farmers are asked to do little bit more, not more, like you said, enlarge the size of the drain, conservative practices. So how are we going to convince them? Like you said, the government needs to do more. Only certain things the government can do. Even we are struggling with the farm bill. What's the mushy middle solution here that we could offer them?
This is tough because the answer is all of the above. There's no one thing. The intersection of human behavior and appropriate solutions is a very interesting one. There's a significant role of economic role, incentives provided by the government, which could include subsidies. They could include, influences on the market. But also knowledge is a big part, and that's what we do here. Because a farmer might want to do something, but they might not know how. They don't know anybody else who's done it. They don't want to be the first person who tries it and fails. So building that network of people who are doing it together and can learn from each other is really important. And part of that is education, understanding how to do it. Part of it is education, understanding why you're doing it. Part of it is showing them practices that will make them an even better steward of their land than they already are, because that's a core value many farmers have. So working with their values rather than against their values. And then part of it too is looking at alternatives. Like probably 10 years ago, I got my first call here at Dept from a local cotton farmer who said, I can see the writing on the wall. I'm moving north. How far north should I go? He was literally wanting me to give him projections of where he should take his cotton farming if he could sell here and move north. I think he ended up in Kansas. So there's multiple different resources we can provide to people. But even if you have the best government policy in the world, if you don't have that learning network, it's not going to happen. And that is so relational. It's so much based on trust. A lot of the papers I went through very quickly, so I didn't highlight the word trust. But every study I looked at what predicates farmer adoption and practices, almost all of them had the word trust in there. Are there people they trust? Is there information they trust? Is there a solution they can trust? And trust cannot be built by government policies. It has to be built by relationships with people. All right. Thank you so much. I know we're at the end of our time, so thank you.
So this concludes our 2024 spring seminar series. Thank you.